Here's a quick test that exposes what an AI model is really built for. Give it one genuinely hard code-based refactor. Most models stream output tokens immediately. They write code as they think, wrapping up in seconds. This one doesn't. Before it emits a single visible token, it routes the prompt into a hidden reasoning buffer. It builds a latent reasoning tree, simulating changes, running static analysis in its head, and pruning dead ends. 15 minutes in, it's still processing that same single request. This is Claude Fable 5. So what exactly did Anthropic build here, and when should you actually use it? Welcome back. Today we're pulling apart Anthropic's new flagship piece by piece. What it is, how the new reasoning buffers actually work under the hood, and exactly when it earns its premium price tag. Let's get into it. So where does this thing actually sit? For a while now, the Claude lineup has had three tiers. Haiku when you need raw speed, Sonnet for balance, and Opus on top, the flagship that's been carrying serious coding work. Fable 5 doesn't replace Opus. It slots in above it a whole new class of model that Anthropic calls Mythos. And the difference is architectural. Opus uses static inference paths. Every token gets the exact same amount of compute. Fable 5 uses dynamic compute routing. It detects complex problems in the reasoning graph and dynamically allocates more GPU cycles to solve them while breezing through simple syntax. It's a fundamental shift in how compute is spent. Under the hood, one design decision changes how this model behaves everywhere else. Reasoning is no longer a feature you switch on. Fable 5 reserves up to 20% of its context window strictly for an internal chain of thought. And there's genuinely no off switch. Ask the API to disable thinking, and it just hands you back an error. What you tune instead is effort. It's not just a delay timer. Turning up the effort dial actually widens the model's beam search. It evaluates multiple solutions in parallel, scores them internally, and only returns the highest probability path. And with a 1 million token context window, that means holding an entire codebase in view with enough memory left over to write back truly enormous, fully validated answers. Everything you've seen so far exists for one reason: long-running agentic work. Hand it one massive job and it settles in as the lead orchestrator. When the work gets complex, the model's context physically partitions itself. It spawns parallel subagents, passing them isolated slivers of the context window so they can work independently without crosstalk. And to keep everyone synced, Fable 5 maintains a shared vector scratchpad. Lessons learned by one worker are written directly back to central memory. So when the final thread finishes, the orchestrator has already compiled the results, run the tests against its own output, and delivered the finished build. Now, before you go and rewrite all your deployment scripts, there's some fine print worth knowing. First, Fable 5 routes every request through a heavy safety classifier layer. It adds latency to every call, and sensitive security work can come back with a hard refusal flag instead of an answer. Second, compliance. Your organization must agree to a strict 30-day data retention policy. Zero retention setups get rejected at the API gate. And then there's the price. It's premium tier, roughly double what Opus costs on every single token. So here's the rule of thumb: keep Opus on the day job and bring Fable 5 in when the problem is genuinely at the edge of what's possible. If this deep dive saved you a long read through the docs, you know what to do. See you in the next one.